Hello, this is Dr. Schott. Dr. Wilson has asked me to answer or attempt to answer a few questions for y'all. So here goes. The first one is, how do scientists estimate when the Big Bang occurred? Well, when you look at celestial bodies in the universe, they are moving out. The universe is basically expanding, and things seem to be moving at a constant rate. And so if we assume that things have been moving at this constant rate, expanding since the beginning of the universe, then you can take the distance they've moved in a given unit of time and extrapolate back to when everything would be back at that central point, that what's known as singularity, when all mass was coalesced into a single unit. And you come to a figure of about 13.8 billion years. Since then, matter has been expanding and changing over time. And that leads us to our second question. If matter can't be created or destroyed, how was so much matter created during the Big Bang? I don't think we should say that it was created, and at that time there would be nothing that we would recognize as an atom. There was matter, but no atoms. Um, there was the matter that gave rise to atoms. Because if you look at this graphic here, you can see early on it was extremely hot and there was not a whole lot of organization in the universe. But as the after the initial Big Bang, as the matter began to expand out, it began to cool and things began to coalesce into first what we would call subatomic particles. And then quite a bit later, we get our first atoms forming. Of course, our most simple atom is hydrogen because it just has a single proton and a single electron. Um, and stars are essentially made of hydrogen and helium. Helium is the next most, helium, complicated atom with two protons and a couple electrons. Um, when stars give off energy, they're doing what's called fusion. That is, they're putting atoms together. And that generates the heat, the energy, the electromagnetic energy that they emit. Um, they also create heavier atoms up to iron. Iron is, I believe, I'm not mistaken, has 26 protons. Um, so essentially, all the different kinds of atoms that we have in the universe are created by stars, and also when stars die, they create even more diverse types of atoms. All right, let's see. Okay, so if everything in the universe came from one tiny particle, where did that particle come from? Where did the initial mass or matter come from? Well, that's a good question. I'm not sure anyone knows. That's sort of the million-dollar question, as they say. What was before singularity? Um, I don't know the answer to that question. Let's see. Next question. Does time actually exist or is it just made up? Um, I think the saying is that time is relative, um, and so here on Earth, of course, we sense time in the passing of days, and obviously one day leads to another, and we call that passing of one moment to another time. And so, yeah, I think in one sense, time definitely does exist because we give a name to this phenomenon, this idea of moments passing. And of course, once one moment passes, it can't come back. Essentially, it's now past. It's in the past and not the present or the future. Um, the thing that is curious to me, and I don't really understand at all, is the idea of time slowing down. And so, if you saw that movie that was out earlier in the year that had Matthew McConaughey in it, I can't think of the title right now, but where it's in the future and he travels off into space. And when he comes back, he is really not aged, but everyone on Earth has. So Interstellar, that was the movie. So that's something that I don't quite understand, but apparently that's real, and the physicists, the really smart people who study this, understand it. And but of course, that has to do with traveling really fast, as in the speed of light, and we don't have the ability to do that. We don't have spaceships that can do that. Whether we ever will, who knows? So yeah, I think time is real, or at least we give a name to this phenomenon of the passing of these moments. How do we date fossils? Um, this is done by a process called radiometric dating, where you use the breakdown of radioactive isotopes, because that breakdown occurs at a constant rate. So these are the isotopes of carbon. The most common one is C12, but then you also have the heavy isotopes, C13 and C14. They have one extra and two extra neutrons, so they're heavier than C12. They're unstable or radioactive isotopes, so they will break down over time. And in a living thing, you have a particular ratio of the heavy isotope C14 to C12. Well, as the C14 breaks down over time, there's less of it, so the ratio changes. Um, and essentially, after 5,570 years, approximately half of the original C14 will be gone. And so you can compare to when it was alive. And so after something has died, you can go to the tundra of Siberia and dig up a woolly mammoth, and you can look at this ratio, and we know what this ratio is in living things. And so we can look at that ratio in the woolly mammoth and see how much is left, and it will give us an estimate of how old or how long ago that mammoth died, essentially. Um, so that's how we do the dating of, quote, fossils, and fossils come in many forms. Um, Carbon works with things that were alive, organic things. If you do rocks and such like that, you have to use other types of elements, and there's a lot of variation in these half-lives. Some have half-lives of millions and millions of years, which can be used to date things that are really old. Um, all right, so we are Homo sapiens. Our ancestor, as far as we can tell, our immediate ancestor was Homo erectus. Um, so essentially, there really is no overlap between when Homo erectus lived and us, because as far as we can tell, Homo erectus gave rise to us, and so Homo erectus ceased to exist after we came about. Um, Now you can see Homo erectus was around for quite a while, and we've been only around for a relatively short period of time. Um, so this second part, Homo erectus evolved into Homo sapiens, yes. So presumably, as Homo erectus evolved into us, it ceased to exist, we would say. Um, all right, so why do scientists suspect that all humans came from Africa? Well, it has to do with the fossil record and the fact that these really early pre-human primates are all found in Africa. And as far as we can tell, they are the species that gave rise to the species that gave rise to the species that gave rise to us. Again, you only find them in Africa. Curiously, it's interesting, you do find Homo erectus in many parts of the globe. And so it appears that Homo erectus migrated out of Africa and populated different parts of the globe. But as far as we can tell, we arose from Homo erectus ancestors that lived in Africa, not other parts of the globe. Um, there's what's called the multi-region model or hypothesis, where humans arose in many different places around the globe from these Homo erectus ancestors. But that's not as widely accepted now as this single origin of humans from Homo erectus populations in Africa, a relatively discrete, small population of Homo erectus that gave rise to Homo sapiens. Okay, why are there ice ages? Well, it has to do with these things called the Milankovitch cycles. And there's three cycles. We're just going to look at the first two, eccentricity and obliquity. And the Earth's orbit is not a perfect circle around the sun. It's somewhat elliptical. And over time, it becomes more and less elliptic. And it does that on a pattern of about 100,000 years. Now, this graphic is very much exaggerated. It's not that different, but that's just for demonstration purposes. But again, it becomes more and less elliptic, or the eccentricity of the orbit varies. The other one is the angle or obliquity of the Earth's tilt to the sun, relative to the sun. And so you can see it shifts over this range. I want to say that now we're at about 23.5, and I think we're becoming less elliptical, if I'm not mistaken, but I'm not positive about that, or less tilted, I should say. So the tilt of the Earth changes, and we won't worry about the third one. It doesn't have necessarily to do with ice ages, but these two, when you put them together, you can get periods in Earth's history when the Earth has a more elliptical orbit. That is, there are some times of the year when it's further from the sun and sometimes when it's closer. And if you combine that with the tilt, such that you have those two cycles, and again, the tilt is on a 41,000 year cycle. And so if they coincide just so, you'll have a period when the Earth is far away from the sun, and it's also at its maximum tilt away from the sun, such that the northern hemisphere at that point, if essentially our winter coincides with when we're really far from the sun, we're going to have really cold winters. And if that is happening just right, that's when you get ice ages. Um, and it's said that we essentially are in the ice age now. We're in periods of when we have very cold climates, but within that so-called ice age, we have glacial periods and interglacial periods. We are in an interglacial period now. The last ice age began or peaked at around, I think, 15,000 years ago, and has been began receding more in the around 11, 12,000 years ago. And so you can see it was much colder during that glacial period, and it began warming up. And again, we're in this interglacial. And so as that climate began warming up, it created the conditions under which agriculture was much more possible. The climate was warmer, and when it's warmer, it's generally easier to raise crops than when it's obviously very cold. Um, and so there were, of course, other interglacial periods in the past when it was warm, but human societies such that they had not really progressed or developed the abilities to practice agriculture. It's only during this most recent interglacial, as you probably learned, when agriculture first started being practiced and spread around the globe. You can see in the recent interglacial, there's of course been some warmer and cooler periods. The climate doesn't stay the same. We're in a warming trend now. And perhaps in history, you'll talk about some of these periods, like the Little Ice Age, that have had some impacts on human history. I know I'm not sure exactly which of these, but one of these dips is when the Vikings had gone and settled into Iceland and Greenland and maybe even Nova Scotia and such. And they went there when it was relatively warm, but then there was a little bit of a cooling period, and their ability to grow food was compromised, and some of those settlements didn't make it. Okay, well that's all I have to say. Good luck with your studies.